Compute the curl of the given vector field. So here we have a vector field F in space. So let's simply rewrite this in its component form. We have components F, G, H. And so our F component here is z squared multiplied by sine of y. Our G component is x times z squared times cosine of y. And then our H component is 2xz sine of y. And we want to compute the curl of this vector field. So let's get started here by finding all of the partial derivatives. The first order partial derivatives for this beautiful vector field. So first things first, we have our F component, again, which is z squared times sine of y. And we want to use this to find the partial derivative of f with respect to y and the partial derivative of f with respect to z. So the partial derivative of the f component with respect to y is going to leave us with z squared times cosine of y. The partial derivative of the f component with respect to z leaves us with 2z times sine of y. So moving on to our g component, we have the g component here is defined as x times z squared times cosine of y. And we want to use this component to find the partial derivative of g with respect to x and the partial derivative of g with respect to z. So the partial derivative of the g component with respect to x is going to be 1 times z squared times cosine of y. And the partial derivative of the g component with respect to z is going to be equal to 2xz times cosine of y. And then last but not least here, we want to consider the h component, which is 2xz times sine of y. And we want to use this to find the partial derivative of h with respect to x, as well as the partial derivative of h with respect to y. So differentiating the h component with respect to x, we are left with 2z times sine of y. And differentiating the h component with respect to y, we are left with 2xz times cosine of y. All right, so now that we have all of these partial derivatives, we're ready to go ahead and compute the curl. So we want to compute the curl of this given vector field. And again, just as a friendly reminder, we know that the curl of our vector field is defined as the partial derivative of h with respect to y minus the partial derivative of g with respect to z, I hat, minus the partial derivative of h with respect to x minus the partial derivative of f with respect to z, j hat, plus the partial derivative of g with respect to x minus the partial derivative of f with respect to y, k hat. And so here we go. We're ready to compute the curl of this vector field using all those partial derivatives that we just found. So here we go. We have 2xz cosine of y minus 2xz times cosine of y, and this is all multiplied by I hat, minus 2z sine of y minus 2z sine of y, and this is all multiplied by j hat, plus z squared cosine of y minus, and we need just a little bit more room, minus z squared times cosine of y, and that's all multiplied by k hat. And so look at what's happening here. Everything is canceling to 0. These two terms cancel. These two terms cancel, and that is a 0. And those two terms cancel. So we are left with that the curl of this vector field is equal to 0 times I hat plus or minus 0 times j hat plus 0 times k hat, right, which is just the 0 vector. So the curl of this vector field is the 0 vector. This is our beautiful final answer. And we can say that this vector field is irrotational. For fun, because math is fun.